Welcome to the 6.6 podcast, Free Fall Explained. And all freely falling objects fall with the same acceleration because the net force on an object is only its weight, and the ratio of weight to mass is the same for all objects. So we're going to talk about Galileo again and refer back to that he showed everybody that everything accelerates equally regardless of mass. And this is true if air resistance is negligible. That's if the objects are in free fall, of course. And it's approximately true when air resistance is very small compared with the mass of the object. So Galileo, what he did was he took a 10 kilogram cannonball and a 1 kilogram stone, and he dropped them, as legend has it, from the Leaning Tower of Pisa, and they struck the ground at practically the same time. And this obviously refuted the Aristotelian idea that an object that weighs more would fall faster than an object that weighs less. So we know that mass and weight are proportional. So a 10 kilogram cannonball experiences 10 times as much gravitational force as a 1 kilogram stone. And these are the two objects that Galileo, according to legend, used in his drop. So we would have to use the mass as well. So 10 times as much force acting on 10 times as much mass produces the same acceleration. So let's see how this works. What we're looking at is the ratio of weight to mass being the same for any objects. So all freely falling objects undergo the same acceleration at the place of the Earth. So here's the 1 kilogram of the stone, and if this is acceleration here, and the force of the 10 kilogram stone is greater, but it also has greater mass. So you can see that the small force over the small mass is equal to the 10 times greater force over the 10 times greater mass. So what he showed was that the ratio of weight to mass is the same. If you want to pause and look at this, you can, but I'm going to move on to the next part. Here's what he showed. Here's his 1 kilogram stone. That's the mass right there. Its weight, which is the force pulling it down, is 10 newtons. 1 kilogram times the acceleration due to gravity. And if you put that over that, 10 kilogram meters per second divided by 1 kilogram gives you 10 meters per second squared, or g. If you look at the 10 kilogram cannonball, which is weighs 100 newtons, that's the force pulling it down, and it has 10 kilograms of mass ratio, then its acceleration is 10 meters per second squared. The way you can always remember this, the way I like to think of it, is that the force pulling the object down is what's pulling it down, but it's also being resisted by the object's inertia. So it's a matter of the force pulling it down over its inertia, and that ratio is always going to be g. The bigger the object, the bigger the force pulling it down, but also the bigger resistance to its change in motion, which is its inertia mass. So here's another picture of Galileo. This is on an old Italian banknote, and you can see there's a picture of Galileo, and also a picture of the Leaning Tower of Pisa, and that's how important he figured, and this event figured into history. So why do all freely falling objects fall with the same acceleration? They all fall with the same acceleration because the net force in the object is only its weight, and the ratio of weight to mass is the same for all objects.